The object of this video is to do some integer subtraction, and actually what we'll be doing here will be applicable to any subtraction of any real numbers. And first we're to find the additive inverse. What is additive inverse? That's just kind of a fancy mathematical expression that means the opposite. So really all we're asked to do down here is to find the opposite of these numbers, and the opposite of 5 is -5. So we found the opposite. And just to verify that it is the additive inverse, you could write the original number plus its additive inverse, and you should get 0 every time. And sure enough, 5 plus -5 is 0. What's the opposite of -4? Well, that would be +4. And sure enough, if we verify that -4 plus what we think is its additive inverse, 4, equals 0, and it does, so it is the additive inverse. And the opposite of 0 is just itself 0, and sure enough, 0 plus 0 is 0. So all additive inverse means is opposite. The next set of 3 problems, we are to find the difference, and difference is just the answer in a subtraction problem. So now it's time to bring in some subtraction rules, subtract rules. And there's not much in the way of rules for subtraction. The first rule is just to change from subtraction, or change from subtract to add the opposite, or add the additive inverse. So we want to change any subtraction we have to add to an addition problem of the opposite. And then from there we just proceed by using the addition rules that we've discussed in a previous video. Okay, so that's not too hard to do. So here's a subtraction. 3 subtract 5. We want to change it to an addition problem. 3 plus, and what's the opposite of 5? That would be -5. And now we just apply the addition rules. We have different signs here, so we take their difference. 5 subtract 3 is 2, and we take the sign of the larger number, which is the -5. So we want a negative sign for our answer. So 3 subtract 5 is -2. The next problem, another subtraction problem, 8 subtract a -4. We change that to 8 plus, and what's the opposite of -4? That's +4. And this is really easy. 8 plus 4, the signs are the same. We just add and take their common sign, which is positive. So our answer is 12. Next problem is written vertically. We can write them vertically as well as horizontally. And we'll just change it to 4 add a -7. And 4 add -7. Once again, the signs are different. So we'll subtract the two numbers. 7 from 4 is 3. And take the sign of the larger, which is the negative. And our answer is -3. The next problem says to evaluate. And the first step in evaluating is to plug in. We'll just plug in place of the variable what it's equal to. So 5 subtract y, and what's y equal to? 6. So we just rewrite this as 5 subtract 6. And now we have a subtraction problem. We change it to an addition problem of 5 plus its opposite, which is -6. Now we apply the addition rules. The signs are different, so we take the difference of the two numbers, which is 1, and take the sign of the larger, which is the negative, and so our answer is -1. The next problem, we want to plug in, substitute in -4 in place of x, and then it says subtract -3. So now here we have two negative signs, a -4 and a -3, and one subtraction sign. You have to kind of look in the context to see how these are used. So we'll rewrite this as -4 plus, now the opposite of -3 is +3. Another case where we have the difference, the signs are different, so that means take their difference. So we're going to go 4, take away 3 is 1. We'll take the sign of the larger, and we get -1. Two problems in a row with the same answer. The next problem is a word problem, very short word problem. Subtract 11 from -4. Subtract 11. Okay, so let me try and change the color of this pen. So we want to subtract 11. That means subtract 11. I've written that. And now subtract 11 from what? Well, from -4. So I put the -4 in front of the subtraction sign. Rewrite it as -4 plus the opposite of 11 is -11. And in this case, our addition rules say the signs are the same, so we add them up. 4 plus 11 is 15, and we take the common sign. Next problem is a longer word problem. Plenty of words in this one. It says the original Badwater Ultramarathon was 146 miles. The race started in Death Valley at an elevation of -282 feet and finished at the top of Mount Whitney at an elevation of, should be of, not on, at an elevation of 14,496 feet. What was the change in elevation from start to finish? If you see the word change, we have a subtraction problem. And notice in this problem we've got some extra information that we won't even need. It's nice information, but we don't need to know how far the race was, 146 miles. But we do need this -282 feet and the 14,496 feet because we want the change in elevation. For change problems, the way to set them up is do the finish amount subtract the start amount. So the finish amount subtract the start amount. And what was the finish amount in this? Well, it finished at 14,496 feet. So from that we want to subtract the start amount, and at the start of the race it started at -282 feet. So we want to subtract a -282. And now remember, it's a subtraction problem, so what do? We rewrite it as add the opposite, and the opposite of -282 feet is +282. And now we apply the addition rules. The signs are the same, so we're just going to add them up and keep the common sign. So just over on the side here we'll add them up. 6 plus 2 is 8, and 9 plus 8 is 17. Carry the 1 and we get 7 here, and a 4 and a 1. 14,778, and the common sign was positive, so our answer is 14,778 feet. That was the change in elevation. It went up, so it's positive, and that is a gain. You might see it sometimes written, the answer as a gain. And so just remember, change subtractions to add the opposite, and you'll be just fine. And I think that's all the time we have for this video. See you in the next one.